Welcome. I'm going to do a quick video tutorial on how to do this lab, all right? So you're opening up three views of a projectile, right? And I can go ahead and hit play. And you can see it from all
Wait.
three views, okay? Now, I don't need to move me. I need to move this, which means I need to move me for a second. Okay. And I'm going to put me back down. Boop. All right, so you can use Frame Advance to actually go ahead, but you need to know exactly where you are. So I'm going to start by putting this little timer out, and it hides back here, but if you hover over the middle of it, you can drag it to a better position. I'm going to put it right there, right? And I'm going to move this up until I am at the frame I want to start with, right? Okay. So keep moving. She's almost shooting it. And here we are, just about to release it. Now, let me show you how to use the meter measuring thing. All right, so I'm going to get this measuring guy over here, and I am going to do the vertical velocity. Now, you got to pick a part of the ball that's easy to measure, and I think you could use the middle, but I think it's actually easier to use the top. So I'm going to just put this right at the top. All right, I'm at my first frame. Uh, and then let me show you how I've configured my data table. So I came down here, and you can just type in things here. And if you want to add in a row, you can go ahead and say like insert column to the right. Okay. All right. So look what I did. I made a frame one because because adding the math for the different frames was a little bit weird, and I realized that one frame is exactly a 60th of a second, and if you put that into your calculator, which I'm going to take entirely too long to do here. Where are you, calculator? There you are. 1 divided by 60 equals. So 0.167. I'm recording. And oops, except I put in an extra thing here. 167. Is that a number? Yes, it is. And if I double that, I get 0.033. Can't type apparently. And if I add another 0.0167, I get, yeah. Okay, so I took the time to add 0.167 to each time to make the times correspond with the frames. Okay, and then I put in some fake data that actually works here, but what you would do to take your data is, I'm on frame 62, right? So then I would just advance the frame, and you can see that the ball rises up. So I could just measure the height of the ball here, and then advance the frame again, and advance the frame again, and advance the frame again. And as they talk about in the instructional videos within this program, you're going to need about 10 points at least to get good data. Okay, so I didn't get a full 10 points, but I can still show you how to do the rest. So you're going to need to make 3 graphs. So I made a horizontal column, a vertical position column, and a vertical velocity column. And the vertical velocity is the one I want to show you how to do. You did this in the free fall lab. Not everyone did it correctly. All right, so this is how they have you do it. And they describe this in this right here, steps to make a velocity graph, but I'm just going to go over it real quickly. All right, so I'm going to configure my bottom axis to time. And for this part of the lab, I'm going to configure my x-axis to, and I put a whole lot of things in here because eventually I'm going to, in the final copy, you need to have all 3 graphs. So you're going to need to have 3 data columns, but for this part where you're figuring out velocity, you don't. So I am just going to go ahead and put in the vertical position, and done. So now we have a graph, and see, you've got this right here. And I'm wondering if I made some kind of crazy error in my data because it does not look as pretty as I like. Where did I get that extra minute of time? All right, I'm going to try to figure out what the heck's going on here. All right, I found my error. So I had miscalculated the time, put an extra 0 here. So I'm going to get rid of that. And my graph still looks really off. I got to figure something out. All right, I figured out my mistake. I forgot zeros here. and here, and here. Now let's look at my graph. Oh, finally, that's what I expected to see, is a parabola starting to level off. All right. Okay, now you need to go up here and you're going to curve fit. Now, this is clearly not a linear curve, but we're going to use the linear curve to figure out as close to the tangential slope as we can. Okay, so perfect would be the slope of the tangent. We don't quite have that. All right, now in order to do this, we need 3 positions, but we need to get rid of the other ones. So this is why you're going to need 10 points when you do it. Now I've deselected these guys, and now I just have 3 dots, okay? And the slope of this line will be the velocity, and if I hover over it, if I do display curve right here, I can see the slope of this line is 18. Now this is made up data, so I've got an 18 slope. All right, so I'm going to come down to my data table, and by down I mean up, and I'm going to put in the slope, which was 18. Now, I'm going to leave the first one, well, the vertical velocity, I'm going to leave the first one blank. And we're going to go here and say this is 18. Okay, and the reason I'm putting it here is because this is the middle dot. If I look up here to my graph, I'm going down. This middle dot, all right, corresponds to my second time. That's the slope we're getting closest to, so it's the middle dot. All right, now I'm going to deselect this guy and select this guy. And you see my slope evens out a little bit. Now we're taking the slope of this point, and it's now 12. So I go up to my data table, and I put in 12. I want you to use this method and not some formula method to figure this out. All right, and then again, I'm going to deselect this, deselect, actually deselect, and select this, actually select, and come down and look at my slope, and it's 5.98. All right, now you'll have a lot more points, so you're going to keep going here. All right, and then I want to talk about your final graph. All right, so your final graph's going to have 3 graphs, and there's only one that you can really show here until I figure out how to make more than one graph in this program. So I want you to put them all on the same axis. All right, horizontal position, horizontal, vertical, and positions, and then vertical velocity. So the way you're going to do that is, now I'm going to come over to configure actually this, and I want to put in my other ones. So I'm going to put in a horizontal position and a vertical velocity. Now I don't have a horizontal position yet, but it'll be there. And then the other thing I need to do is configure some curve fits, right? So curve fits, and even though we used linear to figure out our, try to approximate slope of a tangent, this is not. This is a, it's going to be some kind of a quadratic. Okay. So when I do that, you see a nice, beautiful curve fit. And then I need to do a curve fit for this other one. So horizontal position, I don't have that yet, but for vertical velocity, I am going to pick a linear one for that. All right, and when you're all done, you're going to have 3 different curves on here. All right, so I can see all 3. You're going to have curve fits that make sense for them. And yeah, and then you're going to describe the answers here. Good luck.